Dear friends, in today's lecture we will discuss on conic section. In previous lecture we discussed about nature of the conic, center of the conic, and today's lecture how to reduce into standard form given conic. This is very important topic, how to find the latest rectum, because once we convert into standard form then lot of things are easy to calculate. That's why we needed standard reduce into standard form. So let us start our lecture, and this will be this is the last topic of this unit 1, since unit 1 is smaller than previous other units. In short, our syllabus almost completed. In future we will discuss on MCQ also. Thank you. Good morning dear friends. Now we discuss about problems on conic. We know the general equation of parabola. First of all, standard equations we already studied. Is y square equal to 4ax. Similarly, standard equation of ellipse is x square upon a square plus y square upon b square equal to 1. Standard equation of hyperbola is x square upon a square minus y square upon b square equal to 1. But this is regarding now if you talk about graph, that is symmetric about x axis, means y x is always positive whatever value of y. So x positive in the interval positive x axis. Now this is equation of ellipse. This is graph of ellipse. This is called major axis and minor axis, semi-major and semi-minor axis. Graph for this is like this. This is a hyperbola. So it is not necessary always center for ellipse is origin or vertex for parabola is origin. Here also center is origin, like that. This figure may not at the origin, means sometimes parabola is here at this position. Sometimes ellipse for xy frame, this may be ellipse at this position. then center will be this, then not origin. For parabola it may be like this, not around origin. So we should talk about general equation. So what may be the general equation? So general equation of parabola y minus k bracket sphere equal to 4a x minus h. For ellipse is x minus h whose center is h comma k. General equation for hyperbola is x minus a bracket square upon a square minus y minus b bracket square upon b square equal to 1. Now this is very important. Similarly, we can interchange the role of x and y. Then that is just rotation by 90 degree. For example, this is equation having say y square equal to 4ax. Then such type of parabola having equation x square equal to 4ay, like this. This is the graph of this curve parabola. Now we talk about latus rectum. Latus is Latin word, latus rectum, that is regarding side. So for parabola, if this is the equation, we forgot about this. Latus rectum for this will be the 4a. Now latus rectum for ellipse, all these information is available on Google. If you type latus rectum for parabola, ellipse, like that, this is the formula provided. Equation will be x minus h bracket square upon b a square plus y minus k bracket square upon b square equal to 1, like this. This is the equation of ellipse. So such type of things we needed here, that semi-major axis is there, semi-minor axis is there. That is also we are to study. Then we have to now discuss about some, we have to revise some concept, that is we can denote it as revision. Tan 2 theta equal to 2h upon a minus b, where h, a and b are in general equation of conic. Second is, we already know the trigonometric result. Cos theta is equal to square root of 1 plus cos 2 theta upon 2. Third is, we know the result. We have to use many times. We have to express sin theta is equal to square root of 1 minus cos 2 theta upon 2. Fourth is, we know tan 2 theta trigonometric double angle can be written as 2 tan theta upon 1 minus tan square theta. This result we always needed. Now let us go for problems on conic section. Now we illustrate this concept with example. Reduce the given equation to its standard form and obtain the center. So this is not in standard form. We already discussed standard form in revision topic. Now because here coefficient of x is not 0, coefficient of y is not 0. So first of all we can observe the nature of this equation by taking the term h square minus ab. So h square minus ab, if you compare this given equation with the equation say ax square plus 2hxy plus by square, see ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Then we get the value of a like 7, b like 1. Just compare the coefficient. Here coefficient of x square is a means a equal to 7, like that. We get all values of a, b, h, g, f and c. So just calculate a square minus ab, means 4 square minus a is 7, b is 1. So 16 minus 7 is 9 and that is positive. And if a square minus ab is positive, then we get equation 1 is hyperbola. So in this way we understand the nature. Then we try to find the equation of center of the coordinate conic. That is a point that is called center. We can easily understand the center of circle, center of ellipse, like that center of conic, center of hyperbola, or center of conic is given by this result. Is already discussed in previous lecture. hf minus bg upon ab minus a square, comma, that is point. That's why here this is always going on in two dimensional, in xy plane. So point we can describe, that is separated by comma. Here this is x coordinate, this is y coordinate. Just substitute the value of h, b, g, a, b, h, all these in this result. We get 2, 3. This problem, center of the conic, this is already discussed in previous lecture. So it is not difficult to you to understand the center. So we obtain the center is 2, 3. Now here again understand that we have to shift the origin to the center. So we have get x, we have to replace x by capital X plus 2, y by capital Y plus 3. Then we get new equation, that is 7 capital X square plus 8 xy plus y square minus 9 equal to 0. Now to remove xy term, rotate the axis through an angle theta. And for this purpose we have to use this angle. Why we are rotating? Let me repeat, or let me explain with the help of ellipse, because ellipse is nice figure to understand, that is easy to understand. See here what we have to do. In the problem we have given ellipse like this, whose center is this. We already find the center. say here in this problem 2 comma 3 like that. So such that in per ellipse there may be some center we can easily find. So this is x-axis, this is y-axis. What is next job? Here step 1, find center. Step 2, we have to write into standard form. Want to write into standard form. So what is standard form? What is our target? We have to write this figure like this. This is ellipse, and we already observe the standard shape of ellipse whose semi-major axis is like this, minor axis is like this. So this is standard form. Center is origin or like that. So how we can reach this destination? I will repeat again. This is about origin. This is the standard form. How we can reach to this destination? So we have to apply the step 2. Step 2 is we have to shift this origin. Shift origin to center. To center of the conic. Means this xy will be transferred to this center. Suppose this is a center. So we get new x-axis. This is new x-axis, new y-axis. What is next step? This we already did here. See the. So that's why we get here by shift the origin to the 2 comma 3 means replace small x by x plus 2, capital X plus 2, small y by capital Y plus 3. Substitute in the equation 1. We get 7x square plus 8xy plus y square minus 9 equal to 0. Now what is our next job? Obviously from this diagram we have to rotate this. Rotate by an angle, say theta. So it may be negative or positive, but we have to rotate anyhow. So this is now third step. Again, this is old diagram. Now if you rotate this with some angle, say theta, we get new x-axis and new y-axis. Rotated by theta angle. So that diagram will be look like this. My drawing is very poor, excuse me for this, but I think you understand the intention. That's why we are doing the work about rotation of axis. This is our new axis, this is new y-axis. So in first lecture of this chapter we already did the theoretical part, rotation of axis, translation of axis, like this. So again focus on this. Tan 2 theta equal to 2h upon a minus b. Just substitute a value of h, a, b, we get 4 by 3. From this our target is to obtain cos and theta, cos theta and sin theta. Why? Because we know the formula regarding rotation of axis. In rotation of axis, what we do? We replace in rotation of axis. We are replacing xy by say x dash cos theta minus y dash sin theta, comma, means we replace small x by this one and small y by x dash sin theta plus y dash cos theta. So that's why we needed cos and sin theta. So how we can obtain cos theta and sin theta? We know sin theta is equal to this formula. So from this cos theta is equal to 3 by 5. Why? Sorry, cos 2 theta equal to 3 by 5 because sin theta, tan theta is nothing but the, if the angle is say, this is say 2 theta, then tan 2 theta is equal to AC upon AB. 2 theta is equal to. So, and we know the Pythagoras theorem. If you know the this side and this side ratio, say this is as I say 4:3, then this will be the 5. So ratio will be 3 by 5. So by Pythagoras theorem, cos 2 theta is equal to this side AB upon AC. Cos 2 theta is equal to, note that, cos 2 theta equal to AB upon AC. So ratio having 3 by 5. Note that by Pythagoras theorem, because this is say 4, 3 and 5. So once we obtain cos 2 theta, from this we obtain cos theta and sin theta by this trigonometric result. We know that trigonometry. So friends, we get, instead of here small x and small y, here capital X and capital Y is there. So just here capital X dash, sorry, this will be the, now capital X is equal to this value and capital Y equal to this, because x dash cos theta is square root of 4, means 2 upon square root of 5, and sin theta, that is 1 upon square root 5. So we get in short value of capital X and capital Y. So substitute in this formula 2, equation 2. So we get this one, and just simplify, we get equation 3. So I hope from this equation 3 you can understand easily, that denote the equation of ellipse. Here A equal to 1 and B equal to 3, because 1 square, this can be written as x square upon a square, y square upon b square, minus y square upon b square equal to 1. A equal to 1 and b equal to 3, because 9 is there. So in this way we can reduce into standard form, and that represent hyperbola. Now we go for next problem. Now dear friend, we discuss second problem. Reduce the equation, this equation we have given, to its standard form and obtain the coordinate of the center and length and the equation of axis, lattice rectum, eccentricity of the conic represented by it. So this problem is very important. If you understand this, you can solve all types of problem on this. Again, compare this equation with the standard equation of conic. That means, say ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equal to 0. So we get all values a, b, h, g, f, c, and just check yes, h square minus ab, that is negative. So as per previous lecture we represent that if we know that this for this, if a square minus ab is negative, then implies ellipse. So this is ellipse. Now center of the conic, that is given by this formula. So just substitute the value of h, f, b, g like that, and we get 0, 1. This is the center. Now we have to first step as per discussed in previous problem. Same type of work we have to do. This problem we have to break into smaller parts. First we find the center, and first we find the nature of the conic, that is ellipse, by using a square minus ab calculation. Second step is we find the center, and the center of ellipse is 0, 1. Then we have to shift the origin to the center 0, 1. So we get small, we have to replace small x by capital X plus 0, small y by capital Y plus 1. So we get new equation, and that new equation is (11x square), that is obtained from equation 1, that is 11x square plus 4xy plus 14y square minus 30 equal to 0. Now we have to remove xy. So for the rotate the axis through an angle theta, and that is given by tan 2 theta equal to 2h upon a minus b. In revision topic in the starting of this lecture, we already discussed tan 2 theta equal to 2h upon a minus b. So just substitute value of h, a and b. So we get h is equal to, here we know 2, a equal to 11, b equal to 14. So right hand side will be 4 upon minus 3. And what is about left hand side? We know the tan trigonometric result, tan 2 theta is equal to 2 tan theta upon 1 minus tan square theta. So just simplify this, we get the quadratic equation, factorize it. So this is quadratic in tan theta, is quadratic equation in tan theta. So we know the quadratic equation, how to factorize, means we already know ax square plus bx plus c equal to 0. Its root are given by x equal to minus b plus minus square root of b square minus 4ac upon 2a. So by using this we can find the roots of x. So roots will be, for that is tan theta equal to 2 and minus half. There will be, since it is quadratic, so then we get the two roots, namely 2 and minus half. Tan theta is nothing but slope also. This thing you should remember. So we choose tan theta equal to minus half. Suppose then cos theta is equal to 2 upon root 5. Sin theta is equal to minus 1 upon root 5. Why? Because suppose this is one side, this is another side, say of the triangle. This is the triangle, this is angle theta a, b, c. Suppose this is, its magnitude is 1, its magnitude is 2. Tan theta is equal to ac upon ab. So tan theta is equal to ac upon ab. So we get here we get this side will be root 5 by Pythagoras theorem. So cos theta is equal to adjacent side means AB upon BC, and that is equal to 2 upon root 5. Similarly, we can talk about sin theta, that is AC upon BC, that is 1 upon root 5. So in this way we calculate, but here minus, why minus? Because here minus is there, that's why minus will be there, sin theta. So equation of rotation are, we already calculate the value of cos theta and sin theta, and we know the formula. We can calculate equation of rotation, means in rotation of axis topic we have to replace capital X by this one, capital X by this one, just substitute the value of cos theta, that is 2 upon root 5, just substitute the value of sin theta minus 1 upon root 5, plugging this we get capital X this, and this is capital Y. Please make the correction and substitute this in equation 2. That is, what is equation 2? That is 11 capital X square plus 4 capital XY plus 14 capital Y square minus 30 equal to 0. That we obtained in previous slide, this one. See the equation 2, 11x square plus 4xy plus 14y square minus 30 equal to 0. So in short, after simplifying we get x dash square upon 3 plus y dash square upon 2 equal to 1. And if you compare this standard equation, and that is nothing but the ellipse, and here we get semi major axis as a root 3, because value of a is, if a square equal to 3 then a equal to root 3. Semi minor axis, that is nothing but the b, that is root 2. So major and minor axis are the lines passing through the center. 0, 1, and having the slope is minus half and 2. So we know the equation, that is major axis is the line, and we know the equation of line. General form is y minus k equal to m into x minus h. This is the 1 point form of equation of line. Means if you know the coordinate lie on the line, suppose this is the line and we know the point, say hk is passing through this, and if you know the slope, say m1 or m, then we can calculate with this formula that equation of that line. So we get this line. Similarly we can talk about this one. So friends, there are two slopes, say m1 say equal to minus half, m2 say 2. So at first case slope take as a minus half, we get this one, and we get x plus 2y minus 2 equal to 0 after simplifying. Similarly for slope 2, m2 equal to 2 means y minus 1 equal to 2 into x minus 0. So we get this is equation of minor axis. We can calculate the eccentricity also by the formula b square equal to a square into bracket 1 minus e square. With this, so e equal to 1 upon root 3. So length of lattice rectum is calculated by 2b square upon a, that is 4 upon root 3. Similarly we can solve this problem. Prove that the conic is parabola, reduce the into standard form, find the it is obviously center is infinity by infinity, sorry infinity comma infinity, and lattice rectum also we can calculate. These are for problems for your exercise. You can pause this video and you can write these formulas or problems with the answers, so you can tally, you can solve this problem. If you have any problem, email to me. Solve this equation or remove the xy term, find the center of the following conic and identify the nature. Here answers also given. This is also another third question. I hope you understand this today's lecture, and this is the last topic. This was the last topic of this first chapter. This is very small chapter as compared to previous one. So we all, in short, we completed our syllabus, but in next lecture we will take some MCQ also on this. Thank you. we discuss on MCQ.